All right. Polyatomic ions are going to be groups of atoms with either a positive or a negative charge on them. Sometimes your teacher will just give you a list. If you're going on to AP Chemistry, not so much. But there is a trick on the periodic table that you have that I'm going to teach you so that you don't have to memorize a bunch of them. And then the ones that don't follow the trick are listed on the bottom left of your periodic table. Okay, so you will have this periodic table with you on tests. It's the laminated version that I put in front of you for today's test, okay? And we're going to start by looking at the polyatomic ions that have oxygen attached. So a lot of non-metals have oxygen attached to them, and they often end in ate or ite when that happens. Just to give you a few examples, sulfite, SO3 -2, nitrite, NO2 -1, and there's a bunch more, perchlorate, ClO4 -1, and I'll save you the pain of going through all of them. We're going to go to the periodic table and look at how to come up with their formulas and names because it's a lot easier. So let's take a look at the periodic table. Hopefully I can pull it up easily here. Okay, so I'm looking on the right-hand side. Let's move this. I'm looking at this right-hand side, and we're going to start with something simple, okay? So when I have an oxygen attached to a nonmetal, most of them end in ate or ite. And what we're going to do is we're going to start with this row that's shaded. It's 3443, and it says 8. Okay? So what this tells us is these are the number of oxygen attached to the nonmetal above ending in 8. Okay. Okay, so let me give you an example. If I told you that we have the phosphate, and I'm just underlining the ain't to emphasize it to you. If I have the phosphate ion, sounds like phosphorus is in it, agreed? Okay, so let's come over here to phosphorus. Phosphorus is right here. Since it ends in 8, it would be P and then O4, and then the charge would be -3. Okay, if we have something like the sulfate ion, that sounds like sulfur. So I'm going to come over here to sulfur. It's S, and then go directly underneath it. SO4 -2 is its formula. Okay? If I have something like the chlorate ion, sounds like chlorine. Chlorine is right here. So Cl, go directly underneath it. O3 -1 is the chlorate ion. Okay? What if we're going in the other way, the other direction? So if we're going the other direction, let's say I tell you you've got CO3 -2. Carbon is a nonmetal. It's got 3 oxygens with it. So we're going to go to carbon. Go directly underneath it to the 3. Well, this tells me that I'm going to end in 8. So this would be called the carbonate ion. Okay. If we have something like IO3 -1, iodine's a nonmetal, it's right here. Go directly underneath it to the 3. IO3 -1, so the IO3 tells me that it's going to end in 8. So this is the iodate ion. Yeah.
So can that oxy the oxyanions only form in those 4 columns?
No. The trick will work for these nonmetals that I'm talking about. But some of them are listed on the bottom left of your periodic table.
Okay.
So for those, you can't use the trick. You just have them. Okay? Okay. Now, do you guys see this red circle around the nitrogen right here? And then you've got this arrow going over to this group. Okay? The trick that I'm teaching you right now works for all of the nonmetals except for nitrogen. Okay? So if we have oxygen attached to nitrogen, you have to move over to the other group and use its numbering system. Okay? So traditionally, if you have nitrogen alone, which is N with a -3, N-3 is the nitride ion. However, if you have something like NO3 -1, you would have to travel over here and come down to this 3, and then you're using this charge. So NO3 -1 would be the nitrate ion. Does that make sense? Okay. Okay. Now, besides the 8s, I have 3 other rows of oxygens and different endings. Okay. So can I erase all this and we can go to the other 3 and then we're done with these? Okay. So when we're looking at the ites, which are the row above the 8s, this is 2, 3, 3, 2. These would be the number of oxygens for the polyatomic ions ending in ite. Okay, so if I have something like the phosphite ion, it's phosphorus, you would come down here to the ite row, so PO3 -3 would be the phosphite ion. If I'm looking at bromite, that would be bromine. Bromine is here, BrO2 -1. Okay, so if I have something like silicate ion, that's silicon, that's here, SiO2 -2. Okay, so that's why that -2 is above that group, because for the oxyanions like carbonate, carbonite, silicate, silicite, you can use that -2 charge to get the formulas, okay? And again, if you have something like nitrite, that's nitrogen. It does not follow the group that it's in when oxygen is attached, so you have to come over here. So NO2 -1 would be the nitrite ion, okay? Okay, now let's go to the hypoite one. Can I erase this? Yeah.
Does nitrogen only go over for oxyanion?
Yes. Okay. Now you've got this hypoite row here. And if you go on to take AP Chem, AP Chem tends to stick to a few, like 6 to 8 or so pretty predictable polyatomic ions. If you're going to have like a hypoite or a per-8 or something, they're probably going to give that to you. Okay? So here, if you're looking at hypoite, so this would be for something like the hypophosphite ion. So that contains phosphorus. It would be PO2 -3. Same thing if you had something like SO2 -2. SO2 -2 would be the hyposulfite ion. Okay? And then the very last row here, does your periodic table say per-8 or per-ite? Okay, there's like a ghost that always corrects this back to what it was. I don't know how this happens. This is actually per-8. Okay, so if you have something like the perchlorate ion that contains chlorine, so you would come here, ClO4 -1 would be the perchlorate ion. Okay, I don't think we need to do any more of those. I think you got the idea. Okay, okay, now let's look at the bottom left of your periodic table where all of the other sort of random polyatomic ions are. Okay, so if you're not using that trick and you're like, gosh, this sounds like a really weird thing, I've never heard of it before, look at the bottom left of your periodic table. So you would come down here, and I just want to make sure you understand that the charges, because it's kind of hard to read. The ammonium ion is NH4 +1. We already talked about hydride earlier being H -1. Hydroxide is OH -1. Carbide is a polyatomic ion because it's 2 carbons stuck together with a -2 charge. Cyanide, you guys have probably heard of cyanide pills like in, I don't know, thrillers and stuff like that with spies. So this is CN -1. And then you've got acetate, C2H3O2 -1. Now I want you to rewrite acetate a different way and include it down here just so you have it. So acetate will also be written as CH3COO -1, especially in this book. But you may see it both ways depending upon what you're looking at, okay? And then peroxide, polyatomic ion, that's 2 oxygens stuck together. Thiocyanate, SCN -1. Permanganate, really common one. You will absolutely see that, especially if you take AP Chem. Permanganate is MnO4 -1. Chromate, you will definitely see CrO4 -2. Dichromate, Cr2O7 -2. Pyrophosphate, not so much. Thiosulfate, not so much. Okay? All right, any questions on polyatomic ions? Okay. Do you feel like you need practice writing and naming these, or can I just go and jump into putting them into ionic compounds? You want practice. Take a look at your worksheets, the polyatomic ions worksheet. There are 20 of them. The key is on the next page.